Sure. So today we'll see the problems of kinetic theory of gases and degradation. So this topic consists combination of two topics: kinetic theory of gases and the radiation part. Okay. So there are more than 10 sums under the KTG and radiation. Okay, let's start. So let's start the first one. So let's say the given first. So what is the given here? Let's get the question. Two vessels A and B are filled with the same gas. The volume, temperature, and pressure in a vessel A is twice the volume, temperature, pressure in vessel B. Look, we have two vessels. The first one is A and second is B. So we have the pressure, volume, temperature. We have the pressure, volume, temperature. If the ratio क्या है, that is a 2. So A is a twice of B. Then calculate the ratio of number of molecules of gas A in a vessel that is into B. That is, we need to find the number of molecules in A divided by number of molecules in the B. Okay, so here we find out. Let's go. See, so given, so PA is equal to 2 times PV, then VA is equal to 2 times VB, and TA is equal to 2 times TB as per the given. Okay. Now we need to find, क्या find out करेंगे? We have to find N1 upon N2. अभी यहाँ पे मैंने N1 upon N2 क्यों लिया? Because if you write Na ना, if you write Na becomes Avogadro number. तो ये पहले से allot किया है Na. So rather than taking Na, we can take N1 because Na is Avogadro number. So Na upon Nv लिया, that will indicate its Avogadro number by vessel B का number of molecules. So rather than we'll take Na N1 by N2. Okay. So I think you have get the idea. Let's go for the solution. The solution for that, what is the formula? Number of moles is equal to PV upon R. R is a gas constant, which is a constant for everybody. So if you take the ratio, so what will happen? It will become Na, small na, or small nb. Okay. It will become Pa upon Va divided by R is a gas constant, so it's a constant by Ta divided by Pb, Vb divided by R, Tb. So if you simplify very carefully, it will become Na upon Nb is equal to Pa upon Pb into Va upon Vb into Tb upon Tb. Sure. So this is 2 by 1 or simplify करेंगे अच्छे से. So let's solve it. यहाँ तक पता चला सबको. So this, what is a PA? It's a 2 by PB. So 2 by PB by PB. This is 2 by VB upon VB, and this is TB divided by 2 times TB. Because it reverse है ना. And then 2 get cancelled. So what is remaining? 2 and divided by 2. So what is the answer? It's a 2 by 1. Short, because सब cancel होगा. This will cancel, this will cancel, this will cancel. तो यहाँ पे एक 2 और एक 2 cancel होगा. इसमें से 2 by 1. So number of moles, Na upon Nb is the number of moles. ठीक है? Yeah, this is the number of moles. क्या find out करना है? N1 upon N2, that is number of molecules. So let's move ahead. So ये तो हो गया, एक part हो गया. Let's move for the second one. See, मुझे क्या पता है? Na upon Nb is equal to 1 by 2. मुझे ये पता. मुझे find out करना है N1 upon N2. So how to find? So what is the relation? Number of molecules is equal to, number of moles is equal to number of molecules upon Avogadro number. So if I take Na upon Nb, so what will happen? I'll write N1 upon Na divided by N2 upon Na get cancelled. Answer is N1 upon N2. So Na upon Nb is equal to N1 upon N2. So I can write N1 upon N2 is equal to same as Na upon Nb. And that is 2 by 1. So the ratio of number of molecules of gas in A and B is 2:1. So you can write it's 2:1. This is the answer. Sure. So this is the first question. Simple thought. Let's go for the second one. A gas in a cylinder at a pressure P. Okay. So we have one cylinder and उसमें gas fill up किया, उसका pressure P. That's right. If the mass of all the molecules are made 1/3 of the original, and the speeds are double, then what is the resultant pressure? See simply. What is the initial pressure? P. Then उनका mass क्या किया? 1/3 किया. So we can write m2 is equal to 1/3 of m1, and velocity is a double. Velocity 2 is 2 times of velocity 1. ठीक है? So velocity भी double किया है. What to do? We need to find the क्या find out करना? We need to find the resultant pressure. ठीक है? Let's go for the 2 find क्या करना है? We need to find resultant pressure. So we can write P2 because P1 is P. So what is the solution? First of all, you should know what is the formula. So resultant pressure formula क्या है? P is equal to 1/3 N V M V square bar. See, this V indicate volume, which is a constant because cylinder वही है, उसमें molecule उतनी है, molecules में changes नहीं है. Speed, pressure and mass इसमें change हुआ. Number of molecules is same. Volume is the same. 1/3 is a constant. So the mass change over. Okay. So here I can write a small m, and here I can write small v. Because so यहाँ पे I can write small m is equal to small m1 and small v is equal to small v. I'll write a small. So all are constant. So अगर बाकी सब constant है, so what is the ratio? So it's a p1 upon p2. So what is the ratio? This will become m1 upon m2 into v1 square bar divided by v2 का square bar. Sure. Let's put the value. So what is m1? M1 we don't know. What is m2? It's a 1/3 of m1. Say what is the v1? We don't know what is the v1. What is the v2? It's a 2 times v1. So 2 times it will become square. So this will become 4 v1 square bar. So what will happen? M1 get cancelled. v1 square will get cancelled. So answer is 3/4. So P1 by P2 is a 3/4. Sure? यहाँ तक सबको आया? Sure. So what will do? It is. So मुझे क्या मिला? P1 upon P2 is equal to 3/4. मुझे क्या find out करना है? P2. So what is a P2? This 4 will go here. So 4 P1 upon 3. And what is P1? P1 is a P. So what is a P2? P2 is a 4P/3. Got it? This is the answer. Sure? Sure. Let's move on to the next. Calculate the ratio of mean square speeds of the molecule at a gas at a 30 kPa. Okay. Let's wait. I think same formula. There is one more question based on the same one. Let me check. तो अभी जो फॉर्मूला देखा रिजल्टेंट वेलोसिटी का सेम इक्वेशन. So this one. If the density of oxygen is a 1.44 kg per meter cube at a pressure 105 or 109 10⁵, this is 10⁵ Newton per meter square. Find the Guruji square velocity of oxygen molecule. See what is the given first. See उन्होंने density दी है. Density is 1.44 kg per meter cube. ठीक है. Pressure भी दिया है. So this is density, this is pressure. Okay. 10⁵ Newton per meter square. And what is it to find? We need to find the root mean square velocity. That is v square. No? We can write v max also. Root mean square, it's RMS. So it's RMS square. Okay, you can also write a bar. That's the v RMS square. That is the root mean square. Okay, ये find it. Actually, we need to find this one. V RMS find out because mean root mean square पूछा, that is V RMS. So we'll use the same formula. Let's see. So P is equal to 1/3 N by V M V RMS का square. Okay, 1/3 is a constant. See number of molecules and उसका mass. This is the mass of one molecule and this is the number of molecules. This will become V. So this will become total mass of all the gas of complete gas and this will become volume. So mass upon volume. It's a density. Sure. So what is the formula of Vrms? So Vrms square is equal to 3 times P divided by density. Sure. So let's put the values. So pressure is how much? It's a 10 raised to 5. And density is how much? It's a 1.44. Okay. We'll take a square root. So यहाँ पे square root आएगा directly. So if I take square root, यहाँ पे normal आ जाएगा. So if you solve this term by using calcium, sorry, after calcium locked. So if you solve this sum by using anything, see 144 you can convert it to 12. So easy, right? And this will become 300 all things. So if you use a log table, so what is your answer? The Vrms is 456.44 meter per second. This is your new velocity, RMS velocity. The same formula हमने use किया, लेकिन यहाँ पे total mass is m into n, number of molecules and the total and the individual mass. So it will become complete capital M. So mass upon volume is a density. We'll get answer 456.44. लेकिन log table use करो, then you will get clear answer. Or 144 convert into 12, and then you can do the division. So ये आपको solve करना होगा. Sure. Let's move for the second one. Third one, go for the fourth one. What was the next question? This one. Calculate the ratio of mean square speeds of a molecule of a gas at 30 Kelvin and 120. Simple sum. Given. Temperature 1 कितना है 30 and temperature 2 कितना है 120. And what we require? Mean square speeds. Ratio चाहिए. So 2 5. If you require V1 square bar upon V2 square bar. ये चाहिए. Okay. Now for that you require a formula. So what is the formula of mean square, root mean square of velocity and the temperature? The formula is V square bar is equal to 3 RT divided by M0. See, R is a constant, M0 is a constant, 3 is a constant. So if I take a ratio, it will become V1 square bar divided by V2 square bar. Now what will happen? It's become T1 upon T2. So the answer is 30 by 120. So it's a 1 by 4. So it's a V1 square bar upon V2 square bar. You can also write, if you take a square root on both sides, you have a square root clear to V1 by V2. So it will become 1 by 4. So V1 square by V2 square is 1 by 4 and V1 upon V2 is 1 by 2. Both are correct. Simple था, formula based. तो ये formula पता होना चाहिए, then you get a clear answer. ठीक है? Sure. So we'll have the same formula. इसके बाद आगे sum. Let's see the next one. Show that the RMS velocity of an oxygen molecule is 2 times of the sulfur dioxide at a S.T.P. Okay. That's right. I think this is not 2. This is 2. I think typing mistake. Given. See, what is the molecular mass of oxygen? We have 2 oxygen. So oxygen का molecular mass 1 oxygen is 60. यहाँ पे 2 that will become 32. And what is the molecular mass of उन्होंने बोला second is the SO2 sulfur dioxide. So it is a 64. Sulfur itself 32. Oxygen twice it will become 32. 32 plus 32 is 64. These are the 2 things that is the given. To find तो क्या करना है? We need to find the ratio between the VO2 and VSO2. तो ये find out करना है, ठीक है? Directly go for the solution. See formula क्या है? V square bar. It is the square root. It is 3 RT by M0. So what I write? Let's take a ratio. V of oxygen square bar is equal to V of SO2 square bar is equal to ratio लिया तो क्या होगा? It will become C. At S.T.P मतलब temperature same, R is same, so mass change होगा molecular mass, so it will become 1 upon m0 ना, so it will become, so like mass of SO2 divided by mass of O2. So SO2 is how much? SO2 is 64 and this is 32. So it will become 2 by 1. यहाँ पे side लिखता हूँ. This will become 2 by 1. Now this is square ना? If I take square root on both sides, so this will become VO2 bar, VSO2 bar. This will become root 2 by 1. So what is a VO2 bar? It is a root 2 times VSO2 bar. खत्म. Hence proved. Simple था. 1 or 2 marks. ठीक है? So let's move on to the next one. Next they tell you at what temperature, same formula, okay? At what temperature will oxygen molecule have a same RMS speed as a helium molecules at S.T.P? So molecular mass of oxygen is a 32 and helium is a 4. ये तो दिया है. So given. So उन्होंने क्या बोला कि क्या on at which temperature RMS of oxygen is same as RMS of helium. H2 and He. He. Helium is always individual. Okay, He2 नहीं होता. So at what temperature will oxygen molecule have same RMS? So at S.T.P, so we consider temperature of helium is 273 Kelvin. Let's go 273 as well. So what is the molecular mass of MO2? That is the 32. Like it will become 32 oxygen, right? And what is the molecular mass of helium? 4. Either given. What is to find? Temperature of oxygen. ये find out करना. So let's go for the solution. See, we know the formula. Okay, we know the formula, that is V square bar is equal to 3 RT divided by F0. Okay, so if you take the ratio, what will happen? VO2 square divided by VHE square, it will become 3R. ये तो गया temperature में MO ही बाकी है. This 3R is a constant. So what is the term? TO2 divided by THE into MHE divided by MO2. Okay. Now we know that these two are same. ये दोनों same है, so we can write here 1. Both are same. Na? So if I take a square, still they are same. So it's a 1. We don't know what is a TO2. This is 273. MH is a 4 and this is 32. Okay. So I'll erase this few part so you can solve it. So what will happen? First of all here, the 273. So 4 ones are 4, 4 8s are. So what is a TO2? It's a 273 into 8. Okay, so it will become 2184 Kelvin. If you solve it, this is TO2. So TO2 is how much? 2184. Khatam. Simple type question. Okay. Sure. Let's move to the next. Compare the RMS speed of hydrogen molecules at a 120 centigrade Celsius with the RMS speed of oxygen molecule at 20 centigrade Celsius. So both are oxygen, hydrogen and oxygen, sorry. And दोनों का molecular mass दिया. So what are the given? See, molecular mass of oxygen is 32, and molecular mass of hydrogen, oxygen is a 32 and hydrogen is a 2. Temperature of oxygen is a 120. It's a 27. So we can write 27 degrees Celsius. No? So plus 273 Kelvin. So this will become 300 Kelvin. And T hydrogen, it's 127 plus 270, so it will become 400 K. And what we need to find? We need to find the voltage part. Sorry, speed part. So it will become ratio of hydrogen upon oxygen. Okay, ये find out. Sure, let's go for this one. So what is the solution? V is equal to V square bar is equal to 3 RT by M. So if I compare, if I write VH2 square bar divided by VO2 square bar, so this will become 3 and R is constant. This is 3 of H2 and T of O2. This will become M of O2, M of H2. So if I put the values, TH2 is a 400, or this one is a 300, this one is T 32, and this one is a 2. So this will become 4 by 3. This will become 16. So 4, 16, and 3. So if I take a square root, 4, 16 by 3. So it's a 2 into 8 by root 3. 2 into 8 is a 16, 16 by root 3. So what is your answer? Answer is a 16 by root 3. Let me check. 8 ka square root is 4. Sorry. So 8 ka square root is a 4. So this will become 8 by root 3. Okay. So 16 ka square root is 4. 4 ka square root is 2. 2 into 4 is 8 by root 3. So what is the ratio of hydrogen and oxygen ka velocity? RMS speed is 8 by root 3. Simple. So same formula, there are 2-3 sums. Okay. Let's see the next one. ये तो हुआ है 144 का. Now find the kinetic energy of 5 liter of a gas. Very simple. Kinetic energy find out. So find the kinetic energy of a gas at S.T.P. Given a standard pressure is a 1.013 10⁵ 5. That's a Pascal. So given. What is the given velocity? Volume दिया है 5 liter. So 5 liter means 5 into 10⁵3 10⁻³ meter cube. So 5 liter is how much? 5 into 10⁻³ meter cube. ये पता मुझे. Then standard pressure is how much? 1.013 into 10⁵5. We can write Pascal also or Newton per meter square also. And S.T.P दिया, so temperature is 273 Kelvin. And क्या find out करना? We need to find the kinetic energy. So what is the formula of kinetic energy? Simple. Kinetic energy is 3-2 PV. So what is a P? 1.013 into 10⁵5. And what is velocity? 5 into 10⁻³ So if you solve it very properly, 10⁵5 and 10⁻³ it will become 10⁵2. बाकी सब multiply किया, this whole part. It's a simple calculation. So you get a 7.59. 7.5975 into 10⁵2 joule. So this is your kinetic energy of the given gas. जो कुछ भी gas होगा. So simple formula, kinetic energy 3/2 PV. So this will be for the 1 mark. सिर्फ ये calculation important है, बाकी कुछ नहीं है इसमें. Okay. And temperature used नहीं हुआ. Still it's at S.T.P, so we can get 273 Kelvin as a given. Sure. Sure. इसके ऊपर और एक सम है, लेकिन that will be for 2 or 3 marks. Let's see. This later. Let's see the next one, that is emissive power. Chalo. So emissive power per sphere of an area is 0.02 meter square is 0.5 kilokelvin and divided by s meter square. And what is the amount of heat radiated by the spherical surface in 20 seconds? ऐसे पूछा. See emissive power. Okay. So when emissive power there, so we can get R, that is 0.5 kilocalorie divided by S meter square. Time here 20 seconds. Area is given as 0.02 meter square. So we can write as 2 into 10 raised to minus 2 meter square. And क्या find out करना है मुझे find out करना है, that is how much heat is radiated, that is Q. So if you go through for the formula, so what is the formula? Formula is R is equal to Q by 8. So find out क्या करना है, find out करना है Q. So we can write Q as R80. So you can write small t. Okay. So what is R? R is 0.5. Sure. Then area is 0.02. So I write 2 into 10 raised to minus 2. Then times are 20. So simple. Eh? So this will become 1. This will become 1. 20 into 10 raised to minus 2. So you can also write 0.2 kilocalorie. That is 2. If you want to write in terms of calorie, so this will become 0.2 to 10 raised to 3 calorie. Else you can write in the kilocalorie also. So 2 is 0.2 kilocalorie. Kata, simple tha. So let's go for the second one. Find the temperature of a black body if its spectrum has a peak at. Okay? So there are 2-3 answers in condition here. So let's go one by one. Given. So find the temperature of the black body if its spectrum has a peak value at. So हर एक condition में we need to find the temperature. Okay? Sure. So at the first condition, what is the given? Lambda max is equal to 700 nanometers. Now what we need to find out the temperature. So what is the formula? Formula is a lambda max is equal to B by T. So what is T? It's a lambda max. It's a B by lambda max. It will become B by lambda max. Okay. And everyone knows what is a B. B is a 2.8. It's a 2.897 to 10 raised to minus 3. And what is the lambda max? It's a 700 nanometer. Nanometer of 10 raised to minus 3. So if you use a log table, if you solve it very properly, so temperature for the visible light, or we can write first one, temperature here, so this is the first one. So if you divide this whole term, so you will get the answer as 0.4138 into 10 raised to 4. If you just properly arrange it, it will become 4138 Kelvin. You can log table से solve करना होगा. Okay? So make sure you should know the basics of log table. So it's a 4138 Kelvin. That is the first one. Second is value change. Okay, कुछ भी नहीं. The second term, the values are changing. So what is the lambda max? So 3 centimeter. So this will become T. So 3 matlab 3 into 10 raised to minus 2. So if you divide it, it will become 0.966 into 10 raised to minus 1. So I can write 0.0966 Kelvin. This is your T2 temperature for the second condition. Let's go for the third one. See, third one is a 3 meters, so no need to change anything. So if you just divide 2.897 by 3, you will get the answer very clearly. So it will become 0.966. Same answer because you have 3 to 10 raised to minus 2 है ना बस 10 raised to minus 3. So answer is same. T3 is the same. 0.966 10 raised to minus 3 Kelvin. So A, B, C सब हुआ. Let's go for the next one. यहाँ पे बेस कांस्टेंट भी दिया होगा, okay? But आपको पता होना चाहिए. Let's move for the next one. We will calculate the energy radiated in 1 minute by the black body surface of the area 100 centimeter square when it is maintained at 227 degrees Celsius. So what is the given point? Given is the area is equal to 100 centimeters. So we can get 100 into 10 raised to minus 4 meters square. That is equal to 10 raised to minus 2 meters square. Temperature 227 degrees Celsius. So you can write addition of 273. So it will become 500 Kelvin. Then you should know what is the sigma. Here the sigma is a constant 5.67 into 10 raised to minus 8 joule per meter square. Joule per meter square. And you can also write like this one: joule per meter square second and Kelvin raised to 4. And in 1 minute, so time is 1 minute. You can convert it to 60 seconds. And iske baad what we need to find? You have to find the energy emitted. So that is a Q. Q find out. So formula is simple. Q is equal to the sigma AT, capital T raised to 4. Small t is a time, capital T is a temperature. Okay? These are the Q. Let's find the answer. So Q is equal to sigma AT T raised to 4. Sigma AT T raised to 4. So what is sigma? 5.67. So 5.67 into 10 raised to minus 8. Area is a 10 raised to minus 2. Then इसके बाद क्या था टाइम 60 सेकेंड एंड दिस इज 500 रेज़ टू 4 ना. ये सब आपको लॉग टेबल पे सॉल्व करना होगा. This all things. So if you solve this on a log table, what is your answer? Is it require a log table? I think not. Let's see, 5.67 into this 60 into 5 raised to 4 must have 25 to 25, so 625 into 10 raised to minus 2, 10 raised to minus, it's 10 raised to minus 10. यहाँ पे 2 0 ना, so it's 10 raised to 8. ये सब multiply करो if possible, else you can do the log table. And 10 raised to minus 10, 8, it is become 10 raised to minus 2. Okay, so answer is 21.26 something. 25. This is the answer if you multiply all that. And then let's wait. The answer is 21, 26, 25. The answer. And if you quote this one, 21.2625. And this is a joule. Okay. Okay. So this is the answer. How much energy is edited? 21.26. Let me check. 26.25. So 21, 26.25. 21, 26.25. This is the answer. Sure. Sure. Let's go for the third one. So next is the energy emitted from a hole in an electrical furnace at a rate of 20 watt. When a temperature of the furnace is 720 degrees Celsius, and the what is the area of hole? Area is required. So first we'll write what is a given. See, rate diya na, so it's a dq upon dt. That is a 20 watt. This rate is given. Temperature is a given, that is 727 degrees Celsius. So if I add 273. So what is the answer? Answer is 1000 Kelvin. Then only Stefan constant to the sigma is all things. We need to find the area. So क्या find out करना? We need to find the area. Okay, so let's start with the answer. See, we know that dq upon dt is equal to c. यहाँ पे e आएगा sigma a t raised to 4. यहाँ पे they mention that यहाँ पे e is not mentioned, so we can consider this one as a perfectly black body. So here we can write for perfectly black body t is equal to 1. So we can omit this part. So what is the area here? The area is a dq upon dt 1 upon sigma t raised to 4. So we can put this values. So it could become 20. 5.7 10 raised to minus 8. And what is the temperature? Is 1000. So 1000 raised to 4. ऐसे आएगा. So आपको ये solve करना पड़ेगा. 20 divided by 5.7. 10 raised to minus 8. And this will become 3 and 4. 10 raised to plus 12. So this will become 10 raised to minus 4. And if you solve it, तो आपको आंसर आएगा. This answer is 3.5 into 10 raised to minus 4 meter square. Because area है. So this is answer. 20 divided by 5.7 किया तो it will become 3.5 into 10 raised to minus 4 meter square. ठीक है? चलो simple था. Let's go for the next one. Compare the rate of emission of a heat by the black body maintained at 727 degrees Celsius and 227 degrees Celsius. The black bodies are surrounded by the enclosure at 26 degrees Celsius. And what will be the ratio of their rate of loss? So, दो condition दिया with enclosure. So, for both the condition there is enclosure. This enclosure. So, what is enclosure? Let's take T0. That is at 27 degrees Celsius. Enclosure is how much? 27 degrees Celsius. So we can add a 273, it will become 300 Kelvin. And what is the two condition? T1 is 227. So if I add 273, it becomes 500 Kelvin. What is second condition? The first condition is 726. So it is 727. So this will become 1000. And second is a 227. So this will become 500. Okay. And what we need to find? We need to find ratio of rate of loss. That is same as a dq upon dt. 1 divided by dq upon dt. Now this is also known as R. R1 upon R. dq upon dt is also known as R. So we can have it R1 upon R2 also. Okay. ये find out करें. The formula is the same. Let's go for the formula. See, formula is R or dq upon dt is equal to E, this one, A. And यहाँ पे दो temperature है ना, T1 raised to 4 minus T0 raised to 4, because this enclosure is everywhere. First condition भी होगा, second भी होगा. So this one is the formula. Enclosure is everywhere. So if this is for the first condition, then this was R1. This one is R1. So this is R1 and T1. This part is same because same volume. It's all are same. यहाँ पे T1. What is for R2? It will become dq upon dt का second E sigma A T2 raised to 4 minus T0 raised to 4. So if you take a ratio, it will become R1 upon R2 is equal to T1 raised to 4 minus T0 raised to 4 divided by T2 raised to 4 minus T0 raised to 4. So what are the values? These are the 1000 raised to 4 minus 300 raised to 4 and divided by, this is 500 raised to 4, 500 raised to 4 and minus 300 raised to 4. If I take 100 common, तो यहाँ पे क्या होगा 10 raised to 4 minus 3 raised to 4 divided by 5 raised to 4 minus 3 raised to 4. Now we can do it easily. ठीक है, यहाँ तक देख लेते हैं. So this will become 1000 minus, ऊपर लिखता हूँ. This part. So R1 upon R2, this will become 1000 minus 9, sorry, minus 9. So 27, like 27, 81. And 625 minus 81. So what is the answer? 999, 9919. It's a 9919 and here divided by 544. So if you solve it, you will get a 18.23 by 1. So this is the ratio. R1 upon R2 is 18.21. Okay. Sure. I think this is the last. Let's see. This one is last one. So here we're done with the KTG and radiation. That is the kinetic theory of gases and the radiation. Okay. Sure. So we'll stop. Thank you so much.